Let's say that we have f of x equals 1 minus x, and we are supposed to evaluate the integral from -1 to 2 of f of x dx. Two ways. One, geometrically, and two, using the fundamental theorem of calculus. So geometrically, obviously, we'll need to think about it as how it looks. So 1 minus x is a line. It has y-intercept 1 and slope -1. And so if we want to evaluate the integral from -1 to 2, then we're talking about the area under this curve from -1 to 2. So we have some positive area and some negative area. So positive area will be the area above the x-axis and negative area will be the area below. So that area will be positive. This area will be negative. And area of the triangle is 1/2 base times height. And so the red triangle will be 1/2, and the base is 2 units. And the height is also 2 units. Just double check that. If I plug in -1 into f of x, f of -1 is 1 minus -1, or 1 plus 1, or 2. So this point right here is -1, 2. And then this point on my other end here, that's where x is 2, so f of 2 is 1 minus 2, or -1. So this is the point 2, -1. And this point 1 is where it does cross the axis. If you plug in 1, you get 0. So the area of the little triangle, -1/2, and the base is 1 unit, and the height is 1 unit. So the area, 1/2 times 2 is 1, times 2 is 2. 2 minus 1/2 is 3/2. Now, check the same thing using the fundamental theorem of calculus. It tells us that that definite integral will equal any antiderivative evaluated at the endpoints. So, we have the integral from -1 to 2 of 1 minus x dx. So the antiderivative of 1 is x, minus antiderivative of x is x squared over 2, from -1 to 2. So first I'll plug 2 in, so it'll be 2 minus 2 squared over 2. And then I'll plug in -1, so it's minus, and then -1 minus -1 squared is +1, minus 1/2. So then we have two minus 4 over 2 is 2. So 2 minus 2 minus -1/2 minus 1/2 is minus 3/2. So that's 0 plus 3/2 is 3/2, which is the same answer that we got before. Now, let's say that we have, let's say that we needed to evaluate the integral from -2 to 3 of the absolute value of x minus 1 dx. So we need to see what this looks like. So at x equals 1, so right now I'm looking at the function f of x equals the absolute value of x minus 1. F of 1 equals 0. So I do want to find out where the inside of the function equals 0, because that will tell me my absolute value when things kind of change. And so if x is less than 0, then x minus 1, if x is less than 1, then x minus 1 is negative. And x greater than 1, x minus 1 is positive. So one way that you can deal with an absolute value function is you can rewrite it as a piecewise defined function. So I could say f of x equals minus x minus 1 for x less than 1, and it equals x minus 1 for x greater than 1. Just to double check and show that that's right, for x less than 1, f of x equals minus x minus 1, which is negative x plus 1. That's the one we just had a minute ago. So y-intercept of 1 and slope of negative 1, so down 1 to the right 1, up 1 to the left 1. Except it doesn't ever go here below the axis because it's the absolute value. And so this part gets reflected up, and I get S1, then, hey, Kitty, you're relying on my computer. So let me plug 2 in and see what I get when I plug 2 in. The absolute value f of 2 equals, well, now I'm at the absolute value function, so now when I'm at 2, x is greater than 1, so f of 2 is 2 minus 1, which is 1. And then f of 3 would be 2. So if I want to evaluate the integral from negative 2 to 3, let me find out what the values of the function are at those points. So f of negative 2 is negative 2 minus 1, or positive 3. And then, so that's f of negative 2, and then f of 3. Absolute value of 3 minus 1 is 2. So the integral would be this area, and all of it positive. And so if I wanted to find the areas there, they're all positive. The triangle on the left has base see, this was -2, -1, 0, 1 is where it touches the axis, 2, 3. So the base is 1, 2, 3 units long. And the height is also 3. Now, what about on the other side? That base goes from 1 to 3, so 2 units long. And at 3 we had, what values do we have? F of 3, where did I do that right here? 2. So, 2 long and 2 high, so 1/2, 2 times 2, which gets me 9/2 plus 2, or 9/2 plus, plus 2 plus 4/2 equals 13/2.